Hello and welcome to today's lesson on acceleration. Our learning objective is to apply the formula relating to distance, time and speed for motion with uniform acceleration. Why do you think people buy expensive high-performance sports cars when in reality all cars are limited by the national speed limit? You might say that it's the look of the car or that they're seen as a status symbol, but a huge amount of expense and engineering goes on under the bonnet to make sure that the cars can perform. The reason is not the top speed of the car so much as its acceleration. Acceleration is the change in velocity over time. For sports cars, this is often given as a time that it takes to reach 60 miles an hour from standing still, the 0 to 60 time. The more powerful the car, the quicker it can accelerate. I'd like you to calculate the change in velocity for each of these situations. We'll start with a car that's standing still and it accelerates to 20 meters per second. Write the change in velocity in your books. The change in velocity would be 20 meters per second. What would the change in velocity be if you were travelling at 20 meters per second and you accelerated to 50 meters per second? Write the answer in your book. Would be 30 meters per second. What would the change in velocity be going from 35 meters per second to 70 meters per second? The answer would be 35 meters per second. In this case, the driver is going from travelling at 70 meters per second to travelling at 20 meters per second. What's the change in his velocity? Because he's slowing down or decelerating, the answer would be minus 50 meters per second. And finally, what would the deceleration be if he was travelling at 120 meters per second and slowed down to a speed of 25 meters per second? The change in velocity would be minus 25 meters per second. We calculate acceleration using the equation acceleration is change in velocity over time, or change in velocity divided by time. Here's an example. A motorbike accelerates from 10 meters per second to 37 meters per second in 2.4 seconds. The first step is to work out the change in velocity, the difference between 10 meters per second and 37 meters per second, so plus 27 meters per second, and the time, which we're given as 2.4 seconds, always working in seconds for time. Then we use the equation to find the acceleration by dividing the change in velocity by the time, which gives us 11 meters per second squared. I'd like you now to have a go. Here are 3 questions. Work out the acceleration in each case, and don't forget to put the units, which will be meters per second squared. Pause the video now while you work through that. And here are the answers. For question 1, the acceleration is 7 meters per second squared. For question 2, 2.5 meters per second squared, and question 3, 7.5 meters per second squared. Here we have some extension questions. For the first one, you're working in kilometers per hour and you need to convert that into meters per second, and then you should have no problems. And for the second question, you're trying to work out what the final velocity is when you're given the acceleration, so you'll need to rearrange the equation. If you struggle with this, please don't worry. And for those of you who've managed to answer these questions, well done. The first acceleration was 2.78 meters per second squared, and the second, the velocity, was 160 meters per second. In your books, I'd like you to write a simple definition for acceleration. Pause the video now if you need to. And the answer is that acceleration is the change in velocity over time. Which two of the following measurements do you need to calculate acceleration? Pause the video now while you write your answer in your books. You would need change in speed or change in velocity over time. Once again, in your books, describe the difference between acceleration and velocity. Pause the video while you do that. Velocity gives you the speed of an object in a certain direction. Acceleration tells you how quickly that speed is changing. Velocity is measured in meters per second. Acceleration is measured in meters per second squared. And for the final question, I'd like you to pause the video one last time and answer these two parts of the question. Well, the answers would be 10 meters per second and 30 meters per second. That brings us to the end of today's lesson, so I hope you found that useful, and thank you very much.